Welcome, ladies and gentlemen, to the lesson on quotient identities, where these identities will be used to find the values of trig functions. To quickly recap the trig functions, though, here we are, where sine, cosine, tangent can be broken down into two different ratios using x, y, r when you're on a coordinate graph, and if you're not on a graph, then you use the opposite, adjacent, and hypotenuse method. Same thing with cosecant, secant, and cotangent. Just remember that these are just reciprocals of the original three, and we'll get back into that later. So here's everything put together. Again, when we're on an x, y coordinate plane, that's when you can use the x, y, r variables. Don't forget about the signs of the trig functions. Depending on which quadrant you're in, you'll be able to tell which trig functions are positive or negative. So this was introduced earlier about reciprocal identities, where you can remember that each pair of trig functions or co-trig functions can be used to find the value of each other. So just remember that sine theta is equal to 1 over cosecant theta. In other words, you just flip the fraction to get the value. Cosine is the reciprocal of secant, tangent is the reciprocal of cotangent. Here are the two main formulas you need to know for the quotient identities. For all angles of theta where the denominators are not 0, these identities hold. Combining this with the reciprocal identities, you can find all the values of the trig functions, assuming that you have sine and cosine given to you. So tangent theta is equal to sine over cosine, whereas cotangent is the reciprocal, so it's just cosine over sine. Here's how one of the quotient identities work. So in reality, sine theta is really y over r, again assuming on a coordinate graph. Cosine is x over r. Well, a fraction divided by a fraction is really the first fraction times the second fraction flipped. Combine them together, you get y over x. Well, that happens to be tangent theta. So that's how these identities work. Here's our first example, though, with a couple numbers. These are the ratios that you might be given for sine and cosine, and you might be asked to find tangent. So you set it up by first establishing what tangent theta would be. You would say it's sine over cosine. Okay, so we already know what the values for each one are, so we set it up like this. So it's a fraction over the second fraction, red over blue. But remember, that's the same thing as saying the first fraction times the second fraction flipped. So 2 over the negative square root of 2. We don't need to worry about rationalizing yet, even though there's a square root at the bottom. We're going to first multiply these together. And it's at this step right here, when you combine them, you get negative square root of 3 over square root of 2, because 2 divided by 2 is 1. They cancel each other out. Again, it's really you multiplying them together and then simplifying. At this point, we have a square root of 2 in the denominator, which we don't like, so we rationalize it, and you get the final answer of negative square root of 6 over 2. That's our final answer. If we go to the next example, however, the last one actually, let's say we're given the same trig function values, but we're asked to find cotangent. Well, remember that cotangent is the reciprocal. So you say cosine over sine. Take the blue fraction over the red fraction. But remember, dividing one fraction with another is the same as the first being multiplied with the second fraction flipped, or the reciprocal of it. Combine it together. You get negative square root of 2 over square root of 3, because again, when you multiply these two together, you simplify the 2's into 1, and then you're left with the radicals. But again, you rationalize it because our final answer cannot have square root of 3 in the denominator. So our final answer is negative square root of 6 over 3, which actually is the reciprocal of the previous example of negative square root of 6 over 2. It may not look like it, but remember that if you flip either of these fractions, you would have the square root in the denominator, which you would then have to rationalize, and then you get the same answer. So again, these are reciprocal answers of each other, and there you go. So again, combining quotient identities with reciprocal identities, you can find the values of all the trig functions if you know what sine and cosine are. In the future, you will learn more about how to find other trig function values using different identities.